Okay, so exponents. Let's try not to be scared of them by remembering what they mean. So if I have any number to an integer power, let's say it's x to the power n, what does that mean? Well, if n is a whole positive number, it means we just multiply x times itself n times. Thus, x squared is x times x cubed is x, and so on. Okay, so that's the definition of exponent. So let's see if we can figure out what these things are. We can simplify them a little bit. So this is 5 cubed, and by definition what this means is 5 times 5 times 5. And then we can just compute that. That's 25 times 5. Well, 25 times 4 is 100, so 25 times 5 is 125. And that is my answer there. What about this next one? 2a cubed. Okay. Might be a little scary because we have a variable in here. A is representing some number. I don't know what a is. It doesn't matter. All I have to do is think about this definition. X cubed is x times x times x, no matter what. So, if I have 2a cubed, this is going to be 2a times 2a times 2a. So what is this? Well, this is 6 different things times each other, all multiplied together. We have 3 2's and 3 a's, right? 2 times a times 2 times a times 2 times a. Well, it doesn't matter what order they are, because as long as everything is being multiplied, we could put them in any order we like. So I get 2 times 2 times 2 times a times a times a. Well, this is going to be 8, and this, by definition, is a cubed. Now, some of you might notice something here. You might know of a rule that we could use that would help us find this a little faster. And that rule is that if I have ab to the n, that's equal to a to the n, b to the n. So another way we can do this problem is by using this rule. If we use this rule, how do we do that? Well, let's do it one more time. This is 2 cubed times a cubed. Using the rule, whatever the numbers are, we apply the exponent to each of the numbers, as long as this is all multiplied times each other. It does not work for addition. So, what do I get here? Well, 2 cubed is 8. And notice I get the same answer. Finally, let's do one more. This one has a fraction in it. I'm aware that some of you might be a little worried about fractions. Don't worry. I have 1/3 to the 4th. That's going to be, by definition, 1/3 times 1/3 times 1/3 times 1/3. Well, I know that I can now multiply these fractions, and hopefully I know how multiplying fractions works. I can just multiply the tops, 1 times 1 times 1 times 1, and multiply the bottoms. Well, there's 4 3's there. So 3 times 3 is 9, and 3 times 3 is 9. I can do this in any order. And I get 1/81. Some of you, however, might say, hey, wait a second, isn't there a law for that as well? And there is. And that's a companion to this. So we have a divided by b to the n. That ends up being a to the n over b to the n. So we can do that here as well. We could take 1/3 to the 4th and just take 1 to the 4th over 3 to the 4th. Well, 3 to the 4th, as we found out before, is 4 3's all times each other. So I get 1 over 3 times 3 times 3 times 3, which is 9 times 9, which is 81 as well. So you'll see we get the same answer when we do these both ways. So what's important to remember here? Well, what's important to remember here more than anything else is this definition. Because as long as you remember this definition, you can work straight from the definition, even if you forget how some of the rules work. And I'll just warn you one more time that this rule is for multiplication and this rule is for division. This rule is not for addition. This rule is not for subtraction. So try to keep them straight. As long as the things inside are all multiplied or divided by each other, then we can apply rules to take this shortcut. Otherwise, we can't.